Wouldn't. Let's get into these inequalities here. Okay, so linear, super easy, super easy. Nonlinear, just some fractions. There's going to be some fractions and whatnot in there. We're going to do absolute value inequalities in the model. So kind of the bottom two things we're saving really for the B part for tomorrow. We're doing mostly the top ones, the linear, and then I'm going to show you the nonlinear, aka quadratics. They have x squared in them, and we're going to do some factoring on them. Now, this looks insane to me because there's so many different rules up here. But again, it's very similar to solving equations. Whatever you do to one side, you have to do to the other side. That's what this is really showing you. Like if you're going to add a number, you add it to both sides. Hello, we know that. Same on subtraction. Same on product. Same on all of this stuff, okay? So whatever you do to one side, you do to the other side. The only thing you really have to be careful about is this little bottom with the triple asterisk, little note to remind you of this, because who knows from Algebra 1 if you remember all this good stuff. If you multiply each side of an inequality by a negative number, should put a longer blank, then you reverse the direction of the inequality symbol. So if you multiply both sides by a negative, you reverse the symbol. So if it was less than, you make it greater than, or vice versa. Now, to me, this is almost a little bit misleading in the sense it just says multiply. Because technically, if we're going to get technical, of course, it's multiply or divide. Because dividing is multiplying by the reciprocal also, okay? So I'm also going to put or divide, just so we're obvious and transparent on it, okay? Because obviously dividing is really multiplying by the reciprocal. All right, let's solve some. Let's get into it. Solve the following and sketch the solution set, okay? All right, as always, let's get the x's on one side. Now, normally, it doesn't matter if we subtract the 3x or the 9x. I really wouldn't care, and I really don't care. But when you solve an inequality, you usually want the variable on the left side so you can read it. X is So just to save any work or switching anything around, I always put the x's on the left just to save me a step. So this time, I'm going to subtract 9x. So then I have x on the left. And of course, I'm going to get rid of negative 6. I'm just going to divide it off. Now, divide by a negative. So we're going to reverse our symbol. So I switched it from less than to greater than, and I'm going to reduce this fraction down. Now remember, there's an infinite amount of solutions to an inequality. I could stand up here all day and list numbers greater than negative 2/3. Nobody wants to hear that. That's why they have you sketch the answer on the number line. So I'm not going to get too crazy here. I'm just going to put negative 2/3 on my number line. Now, I don't care when you just have your single number, if you want to put some other numbers on the number line for reference or not. It's up to you. Just for fun for the first one, I know it would be in between like 0, -1 if you want some other numbers. Greater than, open circle, and to the right-hand side. Jade it in. Okay. So any number greater than negative 2/3 is a solution to our inequality. Quick question for you. Is negative 2/3 a solution? Good on the nose. Open circle. You don't have the equal to on your symbol, so just be conscientious of that. Just FYI. And hey, to review, always about reviewing, if you wanted to write this and get fancy in interval notation, you're from negative 2/3 out to infinity. Just for fun, Okay. Now, only thing that's different about this one, clearly the fractions, okay? And you have the variables on both sides. Now, choices. You can keep the fractions if you want, or you know kind of my rule of thumb, 2 or more fractions I clear them, because it's just obnoxious. So I'm looking at my denominators, 4, 2, and 16. The smallest number, 4, 2, and 16, all divide into 16. So I'm going to times everything by 16. Now, if you need to use your calculator, so be it, but let's try to do a little mental math here. If you're looking at this, you're like, but wait, 4 goes into 16 4 times 11x. That's not so bad. I can do that in my head. 16 times 1/2. We can do that in our head. What's half of 16? 8. The 16s would cancel out here, so you just have negative 37, and then 16 times negative x. Now, as always, it really doesn't technically matter which x you cancel out, but inequalities, I know I want my final answer, the x on the left, so I'm going to always keep it on the left. So I'm going to add my 16x over. Total that up, we got 60. I'm going to subtract 8 off, so that's going to put me at negative 45. Greater than or equal to, that's supposed to be not my sloppy handwriting. And then of course let's divide by 60. Okay, no need to reverse the symbol because you divided by positive 60. And I just reduced this earlier, it's negative 3/4. And of course we have to do our number line. I'm just going to do it on the side so I'm not clear at the bottom so you can see okay. And again, when you just have your single answer, you're going to see we'll have multiple answers here in a minute. This time really, if I'm on a test and I'm pinched for time, I'm just going to put my negative 3/4, close circle because of the equal to, greater than's to the right. If you want to put other numbers on the number line, be my guest, but I don't require it. Okay. Any questions on those guys? Hey, it's nice to do some kind of nice easy algebra for a change, right? Okay, compound inequality. Remember, there's two types of compound inequalities, and or ors. Ors, you always have the word or in them. They're pretty obvious. These two are representative of ands. 3x minus 2 is less than 13, and 3x minus 2 is greater than or equal to 4. So 2 for the price of 1, really. Now, same rules. When I get x alone, so I'm going to get rid of minus 2. But I'm solving two inequalities at the same time. So meaning, I got to add 2 to the right and to the left. Everybody's getting a plus 2. And then last step to get x alone, we're going to divide by 3. Everywhere. Middle, left, and right. 15 over 3. Got it. So there's my answer. And of course, number line, we got to represent all our solutions. So this time, because you have x's in between 2 and 5, clearly I'm going to put both 2 and 5 on here. Equal to sign on the 2, so close circle. No equal to sign on the 5, open. And this is telling us x is in between them. We're less than 5 on the left, greater than 2. So I'm just going to shade it. And just for fun to review, that of course corresponds to our interval notation 2, 5. 2 with the bracket because you have the equal to on your including. Do you have to put the interval notation? No. You know I just love to review and I get dramatic. Okay. Another and, but of course, a lot of fractions. No offense, I know how we love fractions, or maybe not fractions. That's why I'm doing a couple more fraction ones for you. Again, my rule of thumb, more than 2 fractions, clear. Make it easy. So denominator's 2, I'd run a 2 to everything. So let's clear them out. So the 2's cancel. 2 times negative 5p, 2 times negative a half, and of course the 2's cancel on the end also. So that's an equivalent inequality. You can solve either one, you'll get the same thing. Elliot.
I have a task to make early. Could I have the homework, please?
Oh, sure, Elliot. That's the easiest question I've been asked today. I like it.
Also, was the homework from Friday already turned in?
Yeah, I can take that for you since you're going to leave early. Yeah, you got it. Okay, moving on. So same deal. I'm going to get rid of the minus 1. And of course, I got to add to the left and the right because you're solving 2 inequalities at the same time. All right, 21 plus 1, 22. So we will get a fraction on that side, but whatever. Be careful here. I know you have to divide by negative 10. That's easy. But you're dividing by a negative 10, so you have to reverse the symbols. Both inequality symbols, both. So this less than, switch it. Switch it. And then, of course, this, I'm going to simplify it down. 2 goes into both. Now, I don't like that. I don't like the looks of that. That's going to cause me anxiety. Because every time we look at anything on the number line, or we do our interval notation, it's smallest to biggest. Is that the order I have that in? Smaller, I got it bigger to smaller. So I'm just gonna do a switcheroo, my friends. I'm gonna put the negative 11/5 first. And then the 1 on the end. Now, the symbols can be tricky, of course. It's because I always have kids are like, wait a minute, you reverse the symbols from the second to last line to the last one. And I'm like, did I actually reverse the symbols? I didn't actually switch around the symbols, I just changed the order of all of this. Notice, pointy part towards P with the 1, pointy part still there, okay? Open part towards P with the 11/5, same thing. So I didn't actually switch the symbols, I just rearranged the order. So just be conscientious of that, that's my spiel. And then of course we gotta do the graph, okay? A little number line, got it. Negative 11/5, you're probably already flipping the page while I was on my rant about symbols. All right, any questions on that guy? So you might have some fraction answers today, some fractions in the problems. My rule of thumb, 2 or more we clear up. Okay, so now we're going to start looking at higher exponents in the problem. Now, to me, this is almost more wordy than it needs to be because you will see as you solve it, it's just going to make common sense to you. Meaning, let's talk about sign of a product or quotient. If a product or quotient has an even number of negatives, it's positive. We know that. 2 negatives make a positive. 4 negatives make a positive. 6 negatives make a positive. Okay. Odd. If you have an odd number of negatives, it's negative. We know that. 3 negatives results a negative. 5 negatives, a negative. Okay, that's not very exciting. We're sick of it. So just some guidelines here to help you out. Because now we're going to start seeing things with squared in them, not just x in them. So, man, this is so wordy. My first rules of advice, just like anytime you solve a quadratic, a squared, you want to have it set to 0. Notice I didn't say equal to 0 because we're going to have a less than or a greater than. We're going to have a symbol. I'm going to have 0 on the right-hand side. I'm going to try to factor it as best my little heart can. Might be, multiply and add. There might be a greatest common factor. Might be difference of squares. I don't know. We'll look at it. And then, of course, the table diagram thing. Diagram the number line. We're going to have the number line, but here's the yuck part. We're going to have to test the number line to figure out if it's an and or an or type of graph. We're going to have to do a little bit of investigating, shall we say, to figure that out. So clearly quadratic, x squared, quadratic. I'm not going to say set it equal to 0. Let's just set it to 0. So I want 0 on the right side. So I'm going to subtract 5x and add 6. So these might be new to you. I don't know if you got into these in Algebra 1, but process pretty similar to solving. Now, we can all factor that. Multiply to 6, add to negative 5. Got it. Now, if we had just an equal to symbol, right now you could tell me the 2 answers. What would the 2 answers be if that was an equal sign? 3 and 2, right? I'm going to write down 3 and 2. That's part of it. That's part of it. Here's the thing, though. We have an inequality. So there's an infinite amount of answers, not just 3 and 2. 3 and 2 are 2 of our answers, but there's an infinite amount of answers. So to find all the answers, now is where I'm going to make my diagram, the number line, and test it. So I'm going to put my answers in the number line in the correct order. Smallest to biggest, of course. So I'm going to put the 2 first, and then the 3. Equal to, so close circles. Now, test the number line. Here's what I mean. These graphs, and I don't want to say always, because there's always an exception to the rules I'll talk about, but they usually turn into either shade in the middle, an and graph, or shade on the outsides, an or graph. Usually. You can have some special cases of all real numbers or no solution, but usually and or graphs. To figure it out, test the number line. So I'm going to pick a number over here on the left to test. I'm going to pick a fraction in the middle to test, and I'm going to pick something on the right-hand side. So I'm going to pick something on the left to 2. I'm just going to keep it easy, and I'm going to throw 1 in there. Now, where am I testing this? Okay, anywhere. You could do the original. You could do this one where I set it to 0. You could do the factored form. I don't really care. Whatever makes the most sense to you. I'm going to do the one set to 0 just because I don't know, I like that one. I'm going to put 1 in here. What's 1 squared? 1 minus 5 times 1 plus 6. So I'm just going to do a little mental math here. I'm going to have 1 minus 5, so I'm going to have negative 4 plus 6, 2. Okay, again. Is that less than or equal to 0? No, it didn't work. I'm not going to shade it. Now, gross. In the middle, I'm going to test 2.5. So you probably want to have your calculator out right now, because even for the sake of time, if I'm on a test, I can't say as I would do this by hand myself either. Because I'm like, oh man, I got to figure out is 2.5 squared plus 6, is that less than or equal to 0? Well, punch it in and see. See what you get. And again, I don't expect to see the work for this. You can just test on your calculator. I don't even care what the final answer is. I just want to know, when you punched this in, was your answer less than or equal to 0? Punch it in. Yes or no? I see you guys now. Yes, you're right. Shade in the middle. So, okay, all right. My gut instinct right now is I'm 99% sure this is just going to be an and graph. We're not going to have any shading on the right side, but we should technically test it. So I'm going to put 4 in. I'm pretty sure 4 squared minus 5 times 4 plus 6. 16 minus 20. That's going to be 2. 2 is not less than or equal to 0, so I'm not going to shade it. So just because I kind of got a mess here with all of this little piddly computation, let's get that out of the way because it's kind of ugly. Okay, final answer. I do not care how you write the final answer. Personally, that's a pretty easy one, I think, to do interval notation on. It doesn't say. I'm just going to say from 2 to 3. I like some interval notation. You can go inequality style, of course. I'm going to circle both. I don't need you to do both. You can pick your poison on it. I think on ands, it's easy just to go interval from the left to the right, done. And of course, I have the brackets on because of the equal to. Okay. Now, B. Everybody just wants to square root B. I'm like, remember your process. Set it to 0, factor it, and test your number line. So I'm going to subtract the 25. It's perfect square, so I'm going to factor it. Now, if it just had the equal to, we didn't have greater than, we had equal to, we all know the solutions are plus or minus 5. So I'm just going to jot those down. They have a fancy name. They're called the critical points, if you wanted to know such a thing. And I'm going to put them on the number line. Of course, smallest to biggest. Okay, and open circles, because we don't have the equal to. And again, I'm going to test the number line. So I'm going to pick a number on the left of -5. I'm going to use -6. This, I think, pretty easy to test in the original one, because the very top one, the one that was given to you. Because what's -6 squared? 36, which sure is greater than 25. So I'm pretty certain this is going to be an OR graph, so my gut instinct is the middle's not going to pass, and the right will. But let's keep testing. 0 squared, 0, no, that's not greater than 25. Okay, I'm going to do 6 now. 6 squared, 36, yep, greater than 25. So we have an OR graph. Now, to write your OR graph, 2 inequalities or 2 intervals. I'm going to do inequality style first. We're less than -5, or x is greater than 5. If you like the interval notation, remember this keeps going, smallest is -infinity up to -5. Or, there's my little symbol, little review for funzo, and then we pick it back up at 5 to infinity. Okay, now math is all about patterns, right? Patterns. Notice less than was an and, greater was an or. Do we think that's generally the pattern on these? Might be, okay. Like I said, 90 whatever percent of the time it's true, but every once in a weird moment you get some weirdo all real numbers or no solution sort of case. All right, I'm looking at C and I'm like, whew, that's fun, okay. Well, it's set to 0. I'm looking at D thinking the same thing. It's set to 0, so that's already done. Okay, cool, great. Remember step 2, factor. Guess what? They factored them for us. Remember, factoring looks like distributing. Don't those look like distributing problems? They sure do to me. So they're already factors, so super swell. We just have to set all of these factors to 0 and get our critical points. So I'm like, oh baby. Now, you can do some of this in your head. I'm going to write it out. We're going to set x to 0. I'm going to pretend it's an equal to for right now. That's one of our numbers. We're going to set x minus 1 squared to 0. I mean, we can do that in our head. What's x got to be? 1. 1 minus 1, 0, 0 squared, 0. And then we're going to set x minus 3 to 0. Now, to me, that's a whole lot of over-dramatic writing. If I was just doing this, of course, and you can too, I would just put, you know, we're going to have 0, 1, and 3. Okay, for your critical points. I was just showing you the math to get to them. Now I'm like, oh man, okay, all right. So I have to put all 3 of those numbers on the number line, which is going to make a lot of different sections of the number line for us to test. Oh, good, fun, okay. I drew a little bigger number line this time because I got to put 3 numbers on. Again, I'm putting them in order. Well, they're in order, but we should always put them in order smallest to biggest. So 0, 1, 3. I know, not drawing the scale necessarily, but whatever. Okay, so let's, of course, open circles. And here is where you definitely probably want to do some testing with your calculator. Do it all by hand. Okay, so I'm going to pick a number on the left of 0. Well, let's just do like -1. Okay, so in your calculator, I'm going to write the first few down. I would never write it. I just do this on my calculator. So I'm looking at -1. Is this whole rigmarole going to be less than 0? You can punch that all in. I'm going to go old school here. -1 minus 1, -2 squared 4, -1 minus 3, -4 times that. I'm going to have 16. 16 is not less than 0. Yeah, see. Okay. Did all that work? It's fine. Whew, boy. Okay, between 0 and 1, let's test a half. We don't have a lot of great choices there. I would definitely type this one in my calculator. 0.5 minus 1 squared. So punch that in. What's written in blue, let me give you a minute. I honestly don't even care what the answer is. I just care, is the answer less than 0? That's what we're after. Is it less than 0? Yeah, so I'm going to shade. And again, I don't expect you to write out all this calculation stuff. You can do that in your calculator. Okay, 1 and 3. Well, let's, I guess, go 2, right? So we got between 1 and 3 for a good pick. So let's put 2 in. So 2 minus 1 squared, 2 minus 3. That's not so bad. I can probably do that in my head. 2 minus 1, 1 squared, 2 minus 3. Oh yeah, when I multiply that together, I'm going to be less than 0. All right, good grief, still going. We're still going. Let's test 4. So check is 4 minus 1 squared, 4 minus, is that going to be less than 0? It is not. Okay, so I'm going to erase all this little rinky-dink little computation because you need to all calculate. Let's get a final answer. This is a fun one for a final answer. Because at first glance, I'm like, oh, cool. 0 to 3. And I'm like, is 1 an answer? No. 1's got this open circle on it. So I can't just be like, oh yeah, 0 to 3. No. Because 1 has the open circle on it. It's not an answer. If that had a closed circle on it, then I would have just said 0 to 3 and been done with it. Doesn't. So I'm going to write it in two inequalities, okay? Or two intervals. I'm going to go interval. I'm going to say, well, we can be from 0 to 1. So anything in between 0 and 1, a lot of fractions on that, that'd be gross. And we could be, or anything from 1 to 3. If you like the inequality style, either version, I don't care. I almost think the interval's easier. So that's just a little, it's obnoxious. That one was obnoxious because we had more numbers to test on the number line, and you had that open circle on there, which made me writing out our final answer a little messier, so to speak. All right, final one of the day. So let's get our answers. Again, you probably can do most of this in your head. You know I'm going to erase this because I'm thinking about if we set these to 0. Well, what number squared times 9 is 0? 0, so 9, 0 over 9, 0, 0. Okay. Plus or minus 0, 0. Okay. This you could factor some more if you really wanted to go perfect squares. Or, of course, -1 and 1. So, do I expect you to write all that stuff out? No. You can just look at it and, mental math. What number squared? 0. Number squared minus 1, 0. Okay, got it. So, number line. Super happy that we have another three critical points to put on the line to test. Okay. Now, careful here, your order. Smallest to biggest. Smallest -1, 0, 1. And I'm going to go our inequality closed circles because we got the equal to. All right, here's where you got to be good on your calculators. Let's start testing. I'm going to test -2. Let's start with that. So I'm going to try to do a little mental math here. -2 squared would be 4. 4 times 9. Got it. -2 squared, 4. 4 minus 1. Whatever that, yeah, that's going to be more than 0. I'm going to shade it. I love it when we have to do a fraction. Between -1 and 0, I guess -0.5. So punch that in. See if that turns out to be greater than or equal to 0. What do you got for -0.5? Does that turn out greater than or equal to 0 when you punch that in? That should be a no. That should be a no. Okay. All right, let's try, more decimals. Between 0 and 1, let's try 0.5. So 9 times 0.5 squared. So punch in the black. Punch in the black. I hope that's not our only shaded region. That'd be kind of depressing. Careful when you're typing them in too, like where the squares are at. All right, when you put in positive 0.5, did that turn out to be greater than or equal to 0? No, Owen's shaking his head. No, he's right. Okay. Okay, well, it's something easy. I can go a whole number now. Let's do 2. I think I can do that guy in my head. 2 squared, 4. 4 times 9, 36. 2 squared, 4. 4 minus 1. Yeah, that'll be. Okay, all right. Whew. Okay, let me erase all this little computation so I get some room to write the final pretty answer. Now for these, I don't know why I tend to like the interval notation better. I just think it's less writing. So we're at -infinity, would be our smallest, up to -1. Now I'm going to use a bracket because you've got the closed circle on it. We're going to pick it up. Our next answer starts at 1 and goes all the way out to infinity. If you like the inequalities, clearly I don't care. X is less than or equal to -1, or X is greater than or equal to 1. Either version doesn't matter to me. So the last few on the homework, I'm not going to lie, they're kind of a pain because you do have more critical points to put on the number line in the testing. I don't need to see the work for the testing. You can just do it in your calculator.